Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Intereference by Chinstrap. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have index lines, where the value in the nth cell along a line, starting from the diamond, indicates the position along the line where the value n appears. For example, if a diamond cell has a value of 3, the third cell along the line must have a value of 1. So this would have to be 1 in this case. If this were a 3, that would force this to be a 1 here. And this is of length 6. So if this would not make sense to have an 8 here because there is no 8th position on this line. So there are certain restrictions that come with index lines that you should not ignore. So basically, again, you can only index to the largest the longest, however long the line is, right? So since this is 6 in length, you cannot index past that 6 in length anywhere along the index lines. So those are examples of how index lines work. We also have self-reference lots, which is why this is Intereference, where digits in a circle count how many cells, including itself, on that line reference themselves. In other words, the digits in the nth cell on the line is the digit n. So for example, say this was only a 4-length index line here. We'll just cut out these two cells. If we had 3, 2, 1, 4, then with 3 in the diamond, it could have the 2 circled because there are 2 different digits referencing themselves. The digits 2 and the digit 4 are in the 2nd and 4th place respectively, right? So the 2 says the 2 has to be in the 2nd spot, so it's self-referencing. The 4 is saying the 4 has to be in the 4th slot, and it's also self-referencing. The 3 is not. The 3 is saying the 1 has to be in the 3rd slot, and the 1 is saying the 3 has to be in the 1st slot. So they're not self-referencing each other. So the digit in the circle references how many digits are self-referencing. And that's how self-reference lots work. And finally, we have a black crop key dot, where the black dot separates digits where one is double the other. So if, for example, this were a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so as I said, you can't go past the number of digits on an index line to reference, so therefore these digits must be 1 through 6. Does not include that. All of these are length 9. This is 1, 2, 3, 4, 5, 6, 7. So this is 1 through 7 here. These are 1 through 9, obviously. These are 1 through 9. These are 1 through 9. So, okay. These are the digits 1 through 7. All of them see this cell here, so this cannot be 1 through 7. Therefore, this is guaranteed to be 8 or 9. These are the digits 1 through 6. All of them see this cell here. So it cannot be 1 through 6. It's guaranteed to be 7 through 9. This digit here has to be the same as one of these three. This digit here has to be the same as one of those two. It also has to be the same as one of these three because we have the digits 1 through... We have these digits, which are the same, and these digits, which have to be different, so they must match these. So these three match those three, period. These three also must match these three, actually, because in this index line, we don't have those digits, so they have to be here, which means they must match those three digits. Interesting. So then these three... these three are not the orange, do not match the green on this line, so they have to be here. So these are the same as these, which are the same as these. And these must be green, green, and green. So whatever digits are here must be the same as these digits, which are the same as those digits. Interesting. What does that tell us? I'm not sure, but it tells us something. So these two digits must match these two. Okay. So we'll make this light and medium here, specifically. So this is light, this is medium. This orange matches that orange, so this must be light and medium here. I guess the oranges will make all darks. So this dark must match those two. Oh! Not necessarily. Hmm. So this is light. This is light. The light has to be one of these three. And this is medium, so that means the medium's one of those three. The dark also must match one of these, so this is dark. So these need to be some combination of pink and green cells. Interesting. This can never be 6, because if that's 6, then it doesn't self-reference itself. Can it be 5? It cannot be 5 either. If this is 5, then that's saying that 3 has to be in the 5th spot, and then there are only 4 self-references amongst themselves. So this cannot be 5 either. Similarly, this can't be 7. This could be 6? No, you can't have a 6 here. So if you have 1 out of place, you're always going to have 2 out of place, right? Because they have to basically reference each other, right? If everything's referencing itself except 1, then that last one must be referencing itself also. So this can never be 6 or 7. It could be 5 then. Okay. This digit then cannot be the same. It's going to be in one of the pink cells every time. And if it's the same, then could be the same digit. But it cannot be 9, is what I was going to say, right? If this is 9, there's no way this can be 9 and still be correct. So this is 1 through 7. Well, I guess this one could actually be 9. This is 1 through 7, and this has to be 1 through 7 here. What else do we know? And this has to be a 1 to 2 ratio here. Okay. Okay. Uh, so there has to be at least one self-reference on every line, but that's all we're guaranteed. Hmm. One, two, three, four, five, six, seven. Okay, that means this cannot be 6, because if this were 6, that would force a 7 to be there, and then that would not match the self-reference. That means 3 cannot be in 5 or 6. So we're guaranteed one of these digits is a 3. Interesting. These digits cannot be in light, medium, or dark. Right? Because these pinks cannot be any of these 6, so it must match these 3. Cannot be this or this. The green here. Yeah. So these 3 digits cannot be here and cannot be here. They have to be these 3. These 4 match these cells here. So we only have 1, 7, 8, or 9 at most in one of these cells. Hmm. Hmm. Um, these have to be some combination of pink and green cells. Interesting. Uh, hmm. So 3 of the digits from 1 through 6 are guaranteed to be these cells. We don't know which. How... Hold on. Can you ever have an odd number of non-self... Sorry. Can you ever have a non... If there are 2 digits... Can you ever have essentially 3 digits which are not referencing themselves? And that extends to, I guess, all odd digits. I think the answer to that is no. Right? You're either referencing yourself or you're referencing another digit which must reference you, right? If you had, say, a 4 here, that's saying 1 has to be in the 4th position, which would force that to be 1, and they're referencing themselves. So, can you ever have 3 self-referencing cells here? I think the answer to that is no, right? Because then 2 of the cells that aren't self-referencing must reference each other, and then the one doesn't have a partner to reference there. So this has to always be even numbers of non-self-referencing pairs, right? So therefore, this must be 2 or 4 here. And I think it's the same for this. This can only be 1, 3, 5, or 7 because you can't have multiple non-referencing cells pointing to, like, in a set of 3. They're always pointing to each other, right? So a non-referencing cell here, say this was 8. That would say a 1 has to be in the 8th spot, so then the 8 would be pointing back to the 1. So they would be pointing at each other as a pair, or they're pointing to themselves. But you can never have 3 sort of pointing to each other. So you're always going to be... So the first of all, it's... Unless it's 9, which this could be, this has to be an odd set of self-referencing digits, because you can't have odd sets of referencing each other pairs, right? There's always you're always going to subtract by 2, right? So this must be then 1, 3, 5, 7, 9. This is 1, 3, 5, 7. This has to be 1, 3, or 5 here. This is 1, 3, 5, 7 here also. So this is 2 or 4, which is saying 3 has to be in the 2nd position or the 4th position. So this cannot be 3 here. So one of these 2 is a 3 here. What does that tell us? Does that tell us anything else? I'm not sure. It's saying, okay, so this is what's saying where 5 can be on this line. So 5 can only be in the 1/3 or 5th or 7th position. This is saying 5 can be in 1, 3, 5, 7, or 9. This is saying 5 can be 1, 3, 5, or 7 here. Interesting. Hmm. 3 is one of those 2. 5, this is 6, right? 4, 5, 6, yes. So 6 can only be in the 1st, 3rd, or 5th position. Okay. That means these cannot be 6. Okay. If the only way this can be 5 here is if this is 7. So if this is 7, that's 5. That means every other digit must be in the correct position. So this must be 1, 2, 3, 4, 6, 8, and 9. Because you have 7 self-referencing digits. That forces this to be 5, 8, 9. So this becomes 4, 7, and 6 here. 4, 6, and 7. That makes us 1, 2, 3. But the problem is, if this is 1, 2, 3, that would mean this has to be 4, 5, and 6 positions have to be related to the 1, 2, 3. So this is not valid. Because of that, we know this can never be 5. So 5 in this index line has to be in 1, 3, or 5, which eliminates 5 in the rest of the row. So these can't be 5. So this cannot be 1 or 3 here. This is 5, 7, or 9 this way. Can this ever be 9 here? I don't think so. That would make this 8, 7, 6, 5, 4, 3, 2, 1. That would mean this is 4, 5, 6. And this would have to be 7, 8, 9, which is impossible. So this cannot be 9 here. Oh, wait, hold up. This is 9. This is saying where 9 can be. Apologies for that. So that's not helpful. Well, okay, so these could be all 5s. These are where the 9s are. So 9 could be here, 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 and here, technically. This is where the 3s are. So 3 can be here, 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 or here. Interesting. So again, this cannot be 7 here, because if we tried 7, that forces this to be 5. That means every other digit on this line must be self-referencing. So this is 9, 8, 6, 4, 3, 2, 1. That makes this 5, 8, 9 here. This is 1, 2, 3. But the 1, 2, 3 says that the 4th, 5th, and 6th digits, 4, 5, and 6, have to be in the first, second, or third position, which is impossible. So then this means this can't be 7. So that means 5 has to be one of these 3 digits here. So 5 in this index line is never going to be in 1, 2, 3. So this is 4, 5, 6, 7, 8, 9. If this were 9, I think we have a similar problem, though. So if this is 9, that forces this to be 8, 7, and then this digit would not fit. So this cannot be 9 here, which means it's 1, 3, 5, or 7. Say it's 7. That might work. No, it doesn't work. Because if this is 7 and that's 9, the problem is that the rest of the line must be self-referencing. So then this must be 8, but then we don't have a value for 1, 3, or 5 in the pink. So that cannot be 7, therefore this is 1, 3, or 5, which means 9 has to be one of these 3 digits. So since that's one of those 3 digits, 9 can never appear here. So 9 has to be 4, 5, 6, 7, 8, or 9, right? So 9 is never here. 9 is either here or it's here. We're not sure which. Okay. If this were 7, then this would have to be 3, because they would be referencing each other. So 3 has to be in the 7th spot, 7 has to be in the 3rd slot. The rest has to be the same. Has to be self-referencing. So that's 1, 2, 4, 5, 6, 8, 9. So this would be 3. This would have to be 1 or 2. That's self-referencing. It cannot be 5 because it's 1, 2, and 7. So this would be 1. So that means there's only one self-referencer. We have just 2 and 7 here. So let's see. This would be 3, 8, and 9. This couldn't be 3 or 5, so this would be one self-referencer. We'd have 2 and 7. This can't be 7 because that would be self-referencing. So this would be 2, that would be 7. This would have to be 8 or 9. But then 1, this 1 means this has to be 5. And we would have a contradiction. So this cannot be 7. Therefore, 3 in this index line must be one of these 3 cells. So this cannot be 3 here. Okay, that eliminates 3 in the rest of the row. So this can't be 3. So 3 is either in red or green. It cannot be in dark. Okay. That means none of these can be 3. So this must be 1, 2, 3, 7, 8, 9 here as possibilities for where the 3 could be. So 3 cannot be in dark. So this can never be 3. Can't be self-referencing. So 3 has to be in 4, 5, 6, 7, 8, and 9. So this is 4 through 9 here, which means it's the same as this digit. So this is 4 through 9. So 7 can only be in green and dark here. 7 can only be in green and dark in this index line, because it's the same as that digit, which is where 3 must be. Interesting. So one of the other ones has to be 4 through 9. Which means we have two non-self-indexers then, or self-referencers. And in light, medium, and dark. So we know green is 3 is in pink or green. 7 has to be in the dark set and the green set. So does one of light or medium. We don't know which. So 7 is in green or dark on this index line. So green and dark here. So this is 1 through 6 here. 7 here would have to be green or dark. So this is 1, 2, 3, 7, 8, 9. Okay. Say this was 9 and this was 1. Okay. That means 9 is in the greens, so 9 would have to be here. So this would have to be 4, 5, or 6. I mean, that seems feasible. There would have to be a 1, so there would be a 1 in the pinks. So this would have to be 4, 5, or 6 also. There would be a 1 in the pink, so this would be 1, 2, or 3. Okay. This cannot be 1 anymore. That seems reasonable. That means... Oh, that's interesting. If this is 1, then this has to be a 2, I believe, right? Because 1 can no longer be here. It cannot be self-referencing itself. It must be referencing another digit, but can't reference 3. So this is only 2 digits, which could be self-referencing then here. Okay. That seems reasonable. Okay, so the only place where this is 9 in the darks is when this is 5. So this is 5, that's 9. There are 5 total self-referencing digits, and this 5 and 9 do not match. So 5 can't be here. 9 is in the darks. So that means this is 7, 8, or 9 here. 9's in the darks here, so that means this is 1, 2, 3. 9 has to be one of these two. We don't know which. This cannot be 5. Oh, that's interesting. So 5 cannot be either of these, so this must be 5 also in self-referencing. 5 is in the pinks. So this is 1, 2, or 3. Okay. We know 5 is one of these 3. So, yeah, the digits 1, 2, or 3. 5 cannot be here. Obviously, neither of these are 5. Interesting. We know at least 2 of these are not self-referencing. They're referencing the other one. So because one of these is not 1, 2, or 3. This would be 4, 6, 7, 8, 9. 7, 8, 9 would be one of these two. Those are obviously not referencing themselves or each other. So that must mean they must be referencing stuff outside. So the last one then must be self-referencing. So you are guaranteed a 1 or a 2 here. So either this is 1 or that's 2, and the other one is 7, 8, or 9 here. Obviously 9 is not here. 9 cannot be here. So 9 has to be one of these 3. We don't know which. 9 is one of those 2 in that instance. This is not 5. This is not 9. Actually, it couldn't be 9 anyways, right? So this is interesting. Ah, okay. It could be. Never mind. Yeah, the 1, 2, 3 came in only in that instance. Why didn't I not include a 7 there? I don't know. 2, 7, 8, 9. None of these could be 9. So 3 is only in 1, 2, 3 or 7, 8, obviously. This can't be 5. 9 is only into the dark spots. So, and this can't be 7. This can't be 9 here. This, since this is 5, well, we don't have the 2 non-referencers. So the problem is this 3 could be referencing something else, right? It could be referencing 4, 6, or 7, 8, 9. Any of those work. That would mean this is not 5 self-referencing. So this is 1 or 3, which would mean 6 would have to be here or here. This can't be 5. These can't be 5 because of the 5 in the column. So 5 would be able to be only in 1, 2, 4, 6, and 7. Okay. Where is the 5 on this line? It's either in 4, 5, or 6. Okay. Hmm. 5 can't be in 2. So 1, no 2, no 3, no 4. It could be in 5. I think that was where I messed up. It's not 1, it's not 2, it's not 3. It's not 6. So there we go. This looks like it's okay. Hmm. Question is kind of, can this be 5? But even if we disprove that, that might be a little problematic. That would be 3 then. These would map to each other, that's fine. So 3 would be in the green. So 3 would be here, 3 would be here, which would force us not to be 4, 6, it's 7, 8, or 9 in this column. So this is 7, 8, or 9. At least 2 of these could be self-referencing, or they could be referencing each other technically. Therefore, this would have to be 4, and this would be 6. But then we'd have a problem there. Because then since this is self-referencing, the 3 is referencing a 7, 8, and 9. The one of the 1 or 2s is referencing a 7, 8, and 9. So that means the remaining digits must be self-referencing, and this must be 4, 5, 6. But then the problem is this 7, 8 is not self-referencing, and they're pointing to each other. We have 3 non-self-referencing here, and another 3 non-self-referencing here. So that would not work for this to be 5. But we still haven't proved that the rest of the digits in that set have to be 5. So one of the pinks is 1 or 3 in that instance, and therefore this would have to be 3. So this could not be 3 here, because there's no way for this index line to have a matching pink with one of these dark cells referencing each other unless this is the dark. So it's 4 and 6. This is 4 and 6. So 7 has to be one of the greens. So since 7 is one of the greens, that means this is 1, 2, 3. That means this is 7 or 8, with one of those being 7. This can never be 3 in that instance. So 3 has to be one of these 2. Which means this is 7 or 8 here. That means 3 is one of these 2. We don't know which. 7 cannot be one of these. So this must be 4 and 6 referencing 3. And 1 of 8 or not. Well, this has to be the 9 referencing 1 of 1 or 2. So this cannot be 8. So if the 7 and 8 were swapped, the problem is they would not be considered self-referencing. And therefore, this would not be self-referencing. This would not be. We'd only have 2 at most. So this has to be 7, which makes this 8. We have 1 or 2 here. So this becomes a 7, 8 pair, which forces this to be 4 and 6. So 3 is self-referencing here. We have a 7, 8 on the line. That would force this to be 9. So 9 is self-referencing. 7, 8 are pointing to 4 and 6. This is 5 and 1 and 2. So 9 is self-referencing, 3 is self-referencing, one of the 1 or 2 is self-referencing, so this does actually kind of work. Would this be correct, though? 5 and 9 are not pointing to each other. I think the answer to this is no. Right? This is 1, 2 with 7 or 8. 9 and 5 are already not pointing to each other. Or are pointing to each other. We have 2 here, guaranteed to be not pointing to itself. So they must match with these 2. So that's 6 already in this index line. So no, this does not work then. So this does not work even if this is 5 and this is 5 and only one of these is 5, this has to be 1 or 3, so therefore these must be matching the 4, 6 here. So this does not work in this scenario. So we've just proven that. But what did we prove? We are trying to prove this 5. This cannot be 5, right? So if this is 5, this is 9, which means none of these can be 5, so this has to be guaranteed to be 5 there. So this cannot be 5. This is 1 or 3 here, which means 9 is not here. 9 has to be in the green. So 9 is here, which means 9 is here, which means 9 is here. Okay, so this cannot be self-referencing. This must be 4, 5, or 6 here. So this is 4, 5, or 6. Interesting. 9 is guaranteed here. It's 1 or 3. 9 must be here. So this is 7, 8, 9. This can't be 9. So 7 could be any of these. That's fine. Okay. What happens? No, that's only 2 and 3, right? If this is 2 and 3, I think that works, right? Because then this is 1. The 1 would have to be 4, 5, or 6 here. That doesn't help too much. What else do we have? Okay, what happens if this is 5 here? So if this is 5, this is 3, which forces this to be 1. So 5 and 3 are not referencing each other. 9 and this other digit is not referencing each other. Therefore, this must be 1. These must be referencing themselves, so it's 2. So 5 and 3 are not referencing each other. Also, this can't be 5. This can't be 3 anymore. So 3 has to be here, which is saying 2 has to be in the third spot. So that's 2. 5 has to be one of these sets. So it cannot be 2, cannot be 6. It's 1, 4, or 5. 1 cannot be here. So this can't be 1 or 2. 1 is in the 4th, 5th, or 6th positions. None of these could be 2. Also, this 7 has to be self-referencing because the 5 and 3 are referencing each other. The 9 and either 4 or 6 are referencing each other. So this must be 7. This must be 8. That forces this to be 7. This is either 6 or 9. Or this is 4 or 9. So this cannot be 7, 8, or 9 here. Oh, and then we have a contradiction. So this can never be 5 either. And the reason why we tried that, yeah. We just wanted to see how restrictive it was, essentially. So this cannot be 5 here. Again, because this 7 has to be, it cannot, 7 in this line cannot be here. And how do we know that? Oh, it's because it must be the same as that digit. So this cannot be 9 because this matches 3. This matches this cell. 3 here has to be in 1, 3, or 5, so it's in green or pink, so it cannot be one of those cells. That, and since this is the same as that digit, then 7 appropriately also has to be in the green or the darks. So 7 here is in the green or the darks, cannot be in the pink. But if we force this to be 5, then this has to be 3. Then we have a 9 matching one of these. So this must match, be self-referencing. 1, 2, one of these is 4. This must be 7. That's 8. But then we'd have 1, 2, and 5 here. And these two don't match the 4 and the 6 here. So that doesn't work. So this cannot be 5. This is 1 or 3. Therefore, 3 cannot be here. 3 is in the pink. Interesting. So 3 is one of the pink. This cannot be 3. 3 has to be one of the pinks. So that means this has to be 3 also. So this cannot be 3 here. 3 must match 4, 5, or 6. So this is 4, 5, or 6 too. So 7 has to be in the green. So 7 and 9 are in the green. Guaranteed. So this is 7 and 9. This cannot be 7. So 7 has to be 7, 8, 9 here. So 7 is here. 9 is here. This can't be 7. So 7 has to be either in 1, 2, 4, 5, or 7. So no 3. So we're guaranteed a 7 here. We have six digits in column 6 now from 1 through 6, which means the remaining digits are 7, 8, and 9. Well, this can never be 7 or 9 because we have the 7 and 9 defined in this index line. So this has to be 8, which means this can't be 8. This is 7 or 9. So that means 6 is guaranteed here to be one of these digits. This is 8, so that's self-referencing. 6 must be one of these digits. That means where is the 2 in column 6? It has to be one of these digits here. So 2 has to be in 1, 2, or 3. And it cannot be here or here. 8 cannot be in the green, so this becomes a 7-9 pair here. So this must be a 7-9 pair. 8 cannot be here. 8 is one of these 3. So one of these is 8, and then the other one's 4, 5, 6. Which means none of these are self-referencing. So this cannot be 5 here either. So 5 has to be in the dark. So 5 cannot be here. 5 is in the dark. 5 is in the dark. And this can't be 8. 8 is in the dark also. So the 8 must be in the dark. So it's either 1 or 2. So that means this is green. Because the 7 or 9 has to be in the green. So this is 1, 2, 7, 9 here. 1 out of 4 or 6 is here. So this still could be 4 here. If this is 4, this becomes 3. These have to be all self-referencing. So it's 1, 2, 5, and 6. That would force this to be 3. So that would force this to be 9. Oh. Hold up, we have more information too. This digit, 7, has to be in 1, 2, and 3. So this is 1, 2, or 3 there. That leaves this as a 4, 5, 6. Which it matches. It cannot be 5. Because one of these 2 is 5. So 5 cannot be where 8 is. So this is 4, 5, or 6. That means 5 is guaranteed. Okay, so 6 is guaranteed to be one of these 2 to match that. That means this is 6 and 5. So this has to be a 5, 6, 8 triplet, which eliminates 5, 6, 8 in the rest of the box. So this must be 4. That means 4, 8 has to be in the 4th position. And this must be a 5, 6 pair here. So 4 has to be one of these 2. This is 1, 2, 3, 4 possibilities. 4 cannot be here, so it can't be self-referencing itself. Huh. This is 1, 2, 7, 9. 9 cannot be here. This is 1, 2, 3, 4. So this has to be a 5, 6 pair. Which means 7 and 9 are 5 and 6. This has to be a 1 or 2. Which does match. This cannot be 4. So the 4th position has to be either 1, 2, 4, 5, 7. No 6. 2 cannot be in 6. This has to be 5 or 6 because this is a 5, 6, 8 triplet then. And this can't be 8, obviously. So this can't be 5 because of the 1, 3 pair in as the 5th digit. So we have 5 or 6 here, which means 3 has to be either 5th or 6th. So this is guaranteed to be 3. You cannot have 3 here. So this is 5, 6, 8, or 9 here. Interesting. What does that mean? This cannot be light. That's one thing that it means. Or I guess it could be light, actually, because 8 could be there still. If this were 1, that would force this to be 3. 3 is self-referencing. 8 is self-referencing. 1 would mean this is 4 and that's 2. So that would work. Therefore, this would be 3. This is 2. This would be 3. And 2 and 4. So 2 would be 7. 4 would 8. 3 means this is 9. So 1 would be self-referencing. So we have 1 self-referencing, 7's not, 9 is not, 8 is not, then 5 and 6 self-referencing. So that would work. 3 self-referencing here means this is 5. So 4 would be self-referencing. And then we have 7 and 9 here. So all of those work. Can this ever be 2 is kind of a question, right? If this is 2, that forces this to be 4. We don't have any other things there. So this becomes 2, 7, 9, 1, 3, 4. So that's 2, which means 8 has to be here if that's the case. So 2 and 8 would be referencing themselves. 8 could not be here. So this would match this cell, so it would not be light. So that seems fine. Okay. Huh. Ah, this can never be 5, 6 because of the 5, 6 pair in the column. So 1 could only be in 1, 2, or 4. So one of these is 1, which means this cannot be 1. So this is 5, 4, 5, and 6. Huh. So if this is 2, if this is 4 and 3, this is 1, and then this is 3. If this is... That's fine. Okay, so... This dark cell cannot be any of these cells. So it has to be one of these two. So it's guaranteed to be one of those two. Can this ever be... If this is 1, obviously this can't be 1. So if this is 1, this becomes 4, right? Which makes this a 5, 6 pair. So that points this to 1. That means this is 2, that's 3. So the 2 and the 3 are referencing each other, 1 and the 4 are referencing each other, therefore this must be 5 and 6. This is 1 referencing itself. That means this is 9. 5, this 6 must make that 5, which makes that 6, so this actually does work. The 2 must be referencing itself, because this one eliminates 1 here, so it's 2. This becomes 3. The 2 must be referencing itself. The 3 is referencing the 7. This is 2, which makes this 8 again. That leaves this as 6, because it can't be 5. So this is 5, which makes this 6. So this is 5, which makes this 7, which makes that 9 and 7. So far that's all fine. 6 is where 1 has to be. So this is 1, that's 3, and this would be 4. And I think we have a contradiction here. How many are referencing? 4 is referencing itself. 3 and 5 are referencing each other. 6 and 1 are referencing... Oh, no, this has to be 7 and this is 9. So that's fine. 2 means this is 4. 8 is referencing itself. 7 and 5 are pointing to each other. 6 and 9 are pointing to each other. So 1 and 3 both work here then, if that's the case. So unfortunately that works too. Dang it. Okay, so this is there. 1 is guaranteed there. That can't be 1. Okay. So what happens if this is 5? If this is 5, then this becomes 6. And everything else has to reference itself, right? Because 5 and 6... Oh, no, that doesn't work. So this cannot be 5. If this is 5, again, that would force this to be 6, but then the 5 would say that 6 has to be in the 5th position. So this cannot be 5. So this becomes a 1 or a 3, which means we have a 1, 3, 1, 3 pair in column 8, which eliminates 1 and 3 in the rest of the column. This can't be 1, this can't be 1, so it's 2. So this can't be 2. Therefore, in the green is 2, 7, 9. So this has to be 2, 7, 9. This can't be 2. This can't be 2. This can't be 2. This 2 points to that cell, so it's an 8. So that matches this. This is not light. This is medium. This is not medium. This is light. That forces this to be 5 or 6. So 4 can never be here. 4, because 4 would have to reference itself. So 4 is referencing itself because this is a 5-6 pair. That means this cannot be 1. This cannot be 2. 4's in the second spot. So this is 4, which means this can't be 4 here. This becomes a 1-3 pair here. 8, 4 points to this can't be 2, and this can't be 2 because they can't point to the 7, 9. Like they can't be there, right, in this line. So this is 2. So we have 7, 9, 7, 9, 1, 3, 1, 3. 2 can only be in the 4th, the 5th, or the 7th spot. So 2 is one of these 3, which means this can't be 2. This 4 eliminates 4 in the rest of the column. 4 cannot be in 1. Could be in 2. Could be in 4, 5, but not 7. Okay. So that means this can't be light. This can't be 8 even. So this is not light. It's okay. 2 has to be one of these 2 digits here. There's no other place for it. Remaining digits in column 8, 5 are 1 through 6. Well, this can't be 2 and it can't be 4. Therefore, this matches this cell. So this must be the blue, which means this is 5 or 6. So this is not, it could be light. In fact, it kind of has to be light, I feel. Maybe not. It's blue, though. So blue cannot be here. Remaining digits in this box, we have a 1, 3, 4, 5, 6 trip. This has to be 5 or 6. We have a 1, 2, 3, 4, 5, 6 sextuplet, so this must be 7, 8, or 9. So this cannot be the dark. It has to be the medium, though. So this is the dark here. So this must be 5 or 6. So this is a 5-6 pair, which eliminates 5 and 6 in the rest of the box. So this cannot be light. It's 1 or 3, which means the blue and the light are the same. So we'll make this, I guess, blue. We have a 5-6 pair here. This can only be 1, 2, or 4, 8 here as possibilities to be in a 1 to 2 ratio. Okay. So 1 has to be one of these digits here. 3 has to be one of these 2 digits here. 1 doesn't actually have to be one of those digits. Can this ever be 2? So can it be 1? It could be. Yeah, never mind. 1, 2, 4, and 3 works. Okay, if this is 4, that's the same. This has to be 5 and 6, exactly. If this is 2, that's the same. That would make this 2 and 3, which would make this 1. So that would be 4. So then this would, again, have to be 5 and 6. So all the darks, all the blues are 6s. So these are all 6s, which means that that's a 6. So this is 5, 5, 5. This is 5, that's 6. Okay. So this only matches 1. So this has to be 1 then, right? It's that this only self-references once. These is not self-referencing, neither is these, neither is this, and this change means that can't be self-referencing. So this is 3, this is 1. That means 1 cannot be here, so 1 has to be there, which means that 4 has to be there, which makes this 2 and 3. This cannot be 1, 5, or 6. It cannot be 4. This becomes a 2, 3 pair here. So we have a 4 here. 5 means 3 has to be in the 5th spot. So this is 3, which makes this 1. So none of these are self-referencing, so these must be to match 3. So that's 7, 9. 3 eliminates 3 here, so it's 1, which means 6 has to be in the first spot, which means this can't be 6. That's 5. So this can't be 6 here. This is a 5, 8, 9 triplet. So 5 can no longer appear on this index line. This can't be 1. 7's either in 2 or 7. We have a 2, 4, 7 triplet here, which eliminates 2, 4, and 7 in the rest of the index line. So this is 3. This 3 eliminates 3 here, so it's 2 and 3. We have 1 self-referencing. So that means 6 is not self-referencing, 5 and 3 are not. It's either 7 self-referencing or 4 is self-referencing. We're not sure which. Well, that matches. Okay. These can't be 5. This can't be 9 here. Remaining digits in... So how many are self-referencing here? 8 self-referencing. And 1 and 3 could be. Okay. This can't be 2 because of the 2 in the row. This can't be 1 because of the 1 in the row. Okay. Remaining digits in column 4. We have 1, 4 with 7 or 9. 1 cannot be here. 4 is one of these digits, so this cannot be 4. Okay. We can remove the coloring now, because it's not as helpful anymore. So 4 is one of these 2 digits. Remaining digits in row 8 are 4, 5, 7, 8, 9. This can't be 4. Oh, this 1 means this has to be a 9. This 3 means this has to be 7. Okay. So this cannot be 9 or 5. This can't be 4. This can't be 7 or 8. Is that helpful? I'm not sure. One of these 2 is 9, so this cannot be 9 here. Therefore, this must be 7, which makes this 9, which makes that 7. Oh, we have the 6 and 9 already referencing them anyways. This 7 eliminates 7 here, so it's 9, which means 9 cannot be either of these cells. So none of these can be 7. This can't be 9 because of the 9 in one of these 2 cells here. This 6 eliminates 6 here, so it's 8, which makes that 6. 8 eliminates 8 here, so that makes that 5, which means this can't be 5. This is an 8, 9 pair here. 6 says that 1 has to be in the 6th spot, which it is. 5 says 3 has to be in the 5th spot, which it is. Okay. Remaining digits, this 7 eliminates 7 here, so this is 2. So that's saying 7 has to be in the 2nd spot, so this is 7. That means 4 is the self-referencing digit. Remaining digits in column 7, we have 1, 3, and 7. This can't be 1 or 3, so that makes this 7. That means 7 cannot be here, 7 cannot be here. 7 eliminates 7 here, so it's 8, which makes this 7. This can no longer be 8, so if this is a 1 to 2 ratio, it's either 1, 2 here, or 4 and 8 here. So this can't... Actually, this could be 4 still with 2 here. Huh. Okay. Remaining digits in column 8, we have 4, 5, 8, 9. This can't be 4, 5, or 9, so that forces this to be 8, so none of these can be 8. That's it. Remaining digits in column 9 are 2, 6, 8, 9. This can't be 6, 8, or 9, so this must be 2, which eliminates 2 from the rest of the column. This can't be 8. This can't be 8. This becomes a 6, 9 pair here. This 8 eliminates 8 here, so it's 9 and 8. That means this can't be 9. It's 4, 5. This 6 eliminates 6 here, so this is 9, which makes that 6. Remaining digits in row 2. We could have 2, 4, 5, and 9. This can't be 2 or 4 because of the 2, 4 pair in the column. Remaining digits in row 3. We have 1, 3, and 7. 7 cannot be here. Where is the 7 in row 3? It has to be here. So that means this can't be 7 here. Remaining digits in row 7. We have 1, 2, 3, and 9. Interesting. So this cannot be 9 here because of the 9 in the column. This can't be 2. We have a 1, 3, 1, 3 pair in column 1, which eliminates 1 and 3 in the rest of the column. Also, if this were 1 and 2, that would force both of these digits to be 3, which is impossible. So this cannot be 1 here. So we're guaranteed a 4 here, which means this cannot be 4 here in the same box. This can't be 4 here, right? This is either 2, 4 or 4, 8. That's the reason why one of these is 4. Remaining digits in row 9. We have 1, 4, 5, and 6. This cannot be 5 or 6. 4 is guaranteed to be here, so this can't be 4, which makes that 1, which makes this 3, which makes that 1. That makes this a 2, so this can't be 2 here. It's 4 and 8, which eliminates 8 here, so it's 7. 1 eliminates 1. This 2 eliminates 2 here, so it's 9. 4 eliminates 4 here, so it's 5 and 4. 5 eliminates 5 here, so it's 9. This can't be 5 or 9, so it's 2. 1 eliminates 1 here, so it's 3, which makes this 1, which makes that 3. This 9 eliminates 9 here, so it's 1, which makes that 4, which makes that 9. This can't be 1 or 9, so it's 3. That leaves this digit as 1 or 5. This can't be 1 because of the 1 in the column, so this is 5, that's 1. This can't be 5 or 9, so it's 4. This can't be 1 or 5 or 4, so that makes that 6. This can't be 5 or 9, so it's 8, which leaves this digit as a 5. And that's a solution. Fascinating, actually. It's really interesting how these index lines interacted. Kind of reminds me of... What does it remind me of? There's another line that's similar to how that worked. I can't remember right now. What's the rule set? Oh, thermometers. Is it thermometers? It's just a lot of times where you have like thermometers like pointing to like multiple sets of digits. It kind of reminded me of that. Was it thermometers? I don't know if it was thermometers. It's some sort of line where you basically had to be... I think it also could be Renband lines, right? Yeah, like Renband lines. Though this had even more restrictions with the index lines. Fascinating, though, really, with the self-referencing. So we had to work out the self-referencing sort of intuitions that we needed. But once we got those, we started being able to whittle things down decently. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.